Hello everyone and welcome to this lecture. In this lecture, we are going to cover the basics of linear learner in AWS SageMaker. So let's get started. All right, so linear learner is a supervised learning algorithm that is used to fit a straight line or a line to my training data. So when I say supervised learning, that means I have input data and I have output data. So basically I have corresponding labels to each of my inputs, okay? Because we are gonna cover other techniques in the future known as principal component analysis, for example, and these are our unsupervised learning techniques. Simply, I only have input data and that's it. And the technique is on its own. It will just gonna, without any labels, should do classification for me, for example. Okay, so linear learner could be used to perform classification and to perform regression tasks as well. Please note that in this case study, we are only going to primarily focus on the regression part. So the first question is, what's the difference between regression and classification? So when I say regression, that means I'm trying to predict a continuous numeric output. So for example, in my case study here, what I'm trying to predict is the salary of an employee. This salary could be $50,000, $20,000, continuous and numeric output. And that's why this basically case study that we have is a regression type problem. However, there are other two types of machine learning in general categories, which is what we call it binary classification, and there is multi-class classification. We're going to cover these techniques in the future case studies, but from a very high level, when I say classification, that means the output could be 1 or 0 when it's a binary classification, for example. So for example, I want to know if a patient, let's say, is healthy or sick. I want to know if my employee, for example, is wanted to retire or not. Stuff like that. Basically, the output could belong to one or two categories. Okay, so in binary classification, we only have two, so either 0 or 1. For multi-class classification, the output must be between 0 and what we call it num classes minus 1. So I actually have num classes. I have a lot of other categories or classes. For example, for let's say self-driving cars, for example, you wanted the car to be able to classify different images from different traffic signs. So it wanted to classify stop sign, yield sign, 30 kilometers an hour, 50 kilometers an hour, and so on. And that's a type of multi-class classification problem. Okay? All right. So for regression specifically, we can train the algorithm to focus on continuous metrics such as mean square error, root mean square error, cross entropy loss, and absolute error. However, for classification, I can train the algorithm to basically optimize or just focus on precision, recall, accuracy, and F1 score. Please note that we're going to cover all these basically metrics again in future case studies. I didn't want to bombard you with tons of metrics and tons of data and tons of concepts specifically in the first case study, because in this case study again the objective is just to get you started. A very simple model in SageMaker, and then once we have that, then in the future case studies we're gonna dig much deeper into a lot more advanced algorithms, a lot more advanced data. We're gonna learn all about these metrics, so that we're gonna come up later. Okay, all right. So let's take a look at some use cases for linear learner. So again, as I mentioned, we can use linear learner for regression tasks, for discrete binary classification tasks, and we can use it for discrete multi-class classification tasks. So for regression tasks, again, the output has to be continuous, numeric. So for example, I want to predict revenue, for example, let's say in next year based on my previous year. So this is an example of a regression type problem. I can use it as well for discrete binary classification. Does my patient have disease or not? I can also use it for multi-class classification, Should an autonomous car, let's say, stop, slow down, or accelerate? Again, these are three different decisions or three different categories or classes, and I can train my model to do that accordingly. All right, so let's take a look at an overview of linear learner. So first, you have to ensure that the data is shuffled before training. So this is critical to make sure that the model does not basically learn the order of the data. And that's why we take the data, we randomly shuffle the data. We also have to make sure that we perform normalization, or what we call it feature scaling. And this feature is actually offered by linear learner as well, which is amazing. So normalization or feature scaling, they are extremely critical processing steps to ensure that the model does not become dominated by the weight of a single feature. For example, let's assume that we wanted to predict the employee salary based on two features, okay? One of them is the number of years of experience, which could be 1, 5, 10, 20, up till 30 years of experience. And I have another feature. For example, this feature might be, let's say, the previous employee salary, for example, in a different company, which might be $50,000 or maybe $25,000 and so on. Become dominated by the previous year, the previous salary, basically, which is again the range of this feature is much larger, is much higher compared to the other one, and that's why we have to make sure that we perform normalization or feature scaling when we run our linear learner, and again that comes pre-prepared for us, so linear learner takes care of that. So linear learner uses stochastic gradient descent to perform the training. Again, we're going to cover the stochastic gradient descent in great details in the upcoming case studies. But from a very high level, what we do here is that we run an optimization problem that can try to optimize and fit the best parameters. Think of this as, again, another optimization technique, such as least sum of squares that we covered before. And we can use different optimizers, such as Adam optimizers. We can use SGD or stochastic gradient descent. And there are so many different parameters that we can, or algorithms that we could use. There are also a lot of hyperparameters that we need to tune, such as, for example, learning rate, for instance. And learning rate is a parameter that will indicate how aggressive you wanted to update the weights. For example, if you increase the learning rate, that means you're asking the model to learn very, very quickly, and you will be able to actually achieve or reach your optimal weights or optimal values much, much faster. However, if you set the learning rate as very small, then it will take you much, much longer to reach your optimized values of parameter. Again, please note, we're going to be covering these techniques in great details in the next case study when we deal with a lot more advanced data set. We can also, when we train the model, we want to make sure that the model does not overfit the training data. And that's why we could use two types of regularization. There is what we call it L1 regularization and L2 regularization. Again, we're going to cover that in great details moving forward. And we can also, what linear learner could do is that you will be able to train multiple models, and you'll be able to optimize them in parallel as well. Okay? All right. So once you have the model, and once your model is trained, then now it's time for validating that model. So trained models are validated against the validation data set, and best model is selected based on the following metrics. So if you're doing regression, you can look at metrics such as mean squared error, root mean squared error, cross entropy loss, and absolute error. And for classification, you can leverage precision, recall, F1 score, and accuracy as well. Okay? All right. So let's take a look at the hyperparameters that come with SageMaker Linear Learner. So this is just a sample of the hyperparameters. So if you guys wanted to check the rest of the hyperparameters, please check them out here. Actually, I have these hyperparameters open. So let's take a look at it. So here I have linear learner hyperparameters. So the following table contains all the hyperparameters for the linear learner algorithm. And please note that the algorithm could be used for regression problems and for classification type problems. Okay, so let's take a look at it. So first we have the feature dimension. This is simply the number of features in the input data. For example, if I'm in my case, I only have one feature. I only have one input, which is the number of years of experience. Here are the number of classes. So for example, if you're using this algorithm for classification, then you need to specify how many classes you are planning to target, for example. You can select here the predictor type. So you can say, I want to go with binary classification, multi-class classifier, or regressor. And please note that in our case study, which is a very simple one, we're going to stick with our regressor because we are doing a regression type problem. Please note that there are tons of parameters in here. I can't go through them all. There are tons of them. There are beta 1, there is beta 2, there is the regularization terms as well. There is L2 regularization term. And we're going to cover regularization and what do I mean by L1 regularization, L2 regularization in the future. But please note again, because in our case study, it's a very simple one. Actually, I'm going to simply ignore most of these parameters. I just need to specify what is my feature dimension. I want to specify, let's scroll down. I want to specify that I'm actually doing regression type problem. And I want to specify, as you guys can see here I have my, let me scroll down. I need to specify how many epochs, which is simply how many passes of the training data they're going to use. So when we train any machine learning model, we simply do that in multiple of iterations. So we feed in the training data many times and we update the parameters. And that's what we call it epochs. And here we need to specify how many epochs that we're going to be running the algorithm for. If you leave it blank, the default is 15, simply put. Okay, again, there are tons of parameters in here. What I want to look for, again, I have L1 regularization parameter. And if you set it to basically 0, that means you don't have any L1 regularization. I can specify my learning rate, which is again how aggressive I want it to train my model. If you set the learning rate to be very high, this is simply the step size, which is like how aggressive you want to update the parameters. If the learning rate is high, that means you will be able to reach your global minimum, which is the best values of the parameters, very, very fast. And if you set the learning rate to be very small, then it will take you much longer to reach your optimized state. This is simply my loss, and that's very important. And I need here to specify if I'm doing regression, which is in my case, I need to specify what is my loss, what is the parameter that I'm trying to optimize or trying to minimize. So I can select squared loss, I can squared absolute loss, I can select again tons of factors here or parameters. I'm just gonna basically stick with the squared loss or the absolute loss in my case, and it will work great. Okay. And again, for if you are using classification, then you can set either auto or logistic, and for multi-class classifiers, you can use softmax loss as well. If you scroll down here we have the batch size, and here basically, which is basically we take our training data and we divide it into batches, and that will be the batch size. Okay, so you can set that parameter here. If not, the default value will be 1,000. And if you scroll down here, I have the number of models. So what's really cool about SageMaker Linear Learner, not train one single model. It actually goes in there and actually train many, many models, okay? And it can select at the end the best model that has been trained for you. So basically all that happens in parallel, and it can select the optimized or the best models out of all of them, which is great. So here you can specify the number of models that you need to train in parallel, basically. And here you can specify the optimizer type. You can say either auto or stochastic gradient descent, or Adam optimizers, or RMS prop. Again, there are tons of optimizers, and we're gonna basically, I would say, try several of these parameters throughout the entire course. And here I have my target precision, I have my target recall, and again, specifically when I'm doing binary classification. And if you scroll down here I have WD, which is my L2 regularization term. Again, I didn't cover regularization in this case study. We're going to be covering it moving forward when we deal with a lot more advanced data set. Okay, all right. So here again, the important parameters that we're going to be dealing with is learning rate, L1 regularization, mini batch size, and WD as well. We're not going to be using this one specifically in this case study, but this is kind of a sample of the parameters that are used with Linear Learner SageMaker. Okay, all right. So the next question is, what are the types of inputs and outputs that I need to deal with or when I train my model? So Amazon SageMaker Linear Learner supports the following inputs data. So first, you can use record IO, and I'm going to show you guys how to convert your data into record IO format and upload that to S3 to train your model. And it only accepts float 32 tensors that are only supported. And again, I'm going to show you how to do that. You can also use text and CSV data, but you have to make sure that the first column is the target label. I know for those of you guys maybe who have done any machine learning before with, let's say, scikit-learn or any other type of packages, you will find SageMaker is a little bit different. It's just a little bit like, you know, it will take you a little bit more time to get used to it, but it's actually after that time, you'll find it's actually pretty straightforward and very intuitive. But here, it's just when you develop or when you feed in your training data, you have to make sure that the first column in the data is your target, okay, is what you're looking for. And then afterwards, you feed in your features or you feed in your input data. You can also support what we call it file or pipe mode. So both are supported in Linear Learner. And for inference, you can simply, the Linear Learner algorithm will support JSON format. So I'm going to show you guys when you have your model and when you run predictions, when you make inferences based on the model, the return or the output will be in JSON format. And for regression, please make sure that you select the predictor type to be a regressor. And simply because again, the algorithm can be used to perform binary classification and can be used to perform multi-class classification as well. And the score is the prediction produced by the model. And I'm going to show you guys how to calculate the score and assess and evaluate the linear learner model. Okay, so the last point is, what about the EC2 instances? Okay, like I need to run this model on a compute. Basically, like I need to select either a CPU or GPU. So linear learner algorithm could be trained on a single CPU and GPU instances. And again, because it's very simple, and in our case, it's actually very, very simple data, just a single CPU will be very, very extremely enough. And you can also train it on multi-machine CPU and GPU. But for testing, the AWS recommends not to use multi-GPU computers. They are not necessary. You're just going to pay a little bit more money and you're not going to get much value out of it because again, the algorithm is very, very simple. Okay. All right. So that's all what I have for this kind of, overview of SageMaker Linear Learner. So please stay tuned and please enjoy AWS SageMaker practical course, and I will see you guys in the next lecture.